Hey guys, welcome back. In the series of learning programming in C, in the previous videos, we have already discussed about many topics on C. So please do check out the link of those videos in the description. So one among that is the language translators that what we have discussed. So we have seen the different types of translators, compiler, interpreter, assembler, and we have seen the translation process also. But there are still many more things that what we need to discuss about these translators. So in today's video, we will discuss about the compiler, the compilation process in detail. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notifications of all the new videos. Don't skip the videos. Please watch the videos till the end. So this is what the model that what we have seen. So we have the source program, translator program and the object program. The source program is a program that what we write using the high level language or assembly level language. So here I have taken it as high level language. So high level language is the language which is very nearer to the user. It is user friendly language and it is very far to the machine, because machine uses the binary code zeros and ones, and here we use the English like statements. So if we write the program using high level language, so I can use any languages like C, C++ and Java, Python, whatever it may be. So if I write a program using C language, my program, I need to save it with an extension .c. See, every file will have its own extension. So let me say my program is demo.c. When I give this source code or source program to the compiler will check the complete program. It takes the whole program, it is going to check for the errors. If there are any errors, it is going to list out those errors, and we the users have to solve those errors. And once when your program becomes free from errors, it is going to translate that. So translator program is going to do the translation and I'm going to get the object code. So that is what we have learned here. But this complete compilation process involves many other phases. So those phases we have to study now. So when I talk about this source program given to the compiler, there is one more phase which comes into picture here, and the output of that will be given to the compiler. Then I say the compiler translates your program and it converts to the object program. But again there is one more phase which comes into picture, and the outcome of that will be the object program. And then you will link your object code with various definitions of the built-in functions. Then finally you create one single file. Then you load the program and the execution starts, you get the output. So here we say the compiler model works in three stages. So it is translation, linking and loading. So this is what the model that what we have seen already. So in the language translators topic, I have discussed about this in detail. So please do watch the videos of that. And here I can say that these stages where I say translation is done by compiler, and this compiler has many other phases to get this object code, object program. And that object code is linked to its various definition of built-in functions. Or when I say it's a complete program, I will have many object codes. I need to link all those object files and make it as one file. Then I have to load that to the memory, that is main memory, that is RAM, because I need to give it to the processor for processing. Then I'll get the output. So this is what the stages: compilation, then translation takes place, linking and loading. So here is the sample program that what I have written here to explain the complete process of compilation and execution. So as I said, this source code, the source program is given to compiler, and compiler will take care of translating your source code to object code. But there are many other phases that comes into picture here. And that phase is the preprocessor. So what happens here? The source code is given to preprocessor. So what is this preprocessor? We have many hash includes here. We call them as preprocessor directives. The compiler cannot make out all these hash includes. We also have a macro definition. So the compiler cannot make out this hash define, hash include. All these preprocessor directives can be identified by preprocessor only. So the preprocessor performs few tasks here. So what it is going to do? It is going to remove all the comments first. So we have the comment here, we have single line comment just to provide the heading of the program. So it is going to remove the comment. Then it is going to replace the header files with its code. So it is going to replace the code of header files. Then if there are any macro definition, it is going to replace the value of all these values in your program. So the macro gets replaced. So these are the tasks that what the preprocessor has to perform. So once the preprocessor performs all these tasks, the final outcome that what I am going to get for this is I am going to get the code of the complete source code in a different way. Comments will be removed. I am going to replace the code of the header file. So I am going to get the code of stdio.h. So we have included this stdio.h and header file to get the definition of this inbuilt function printf. Well, I have discussed about this in the structure of C. Please do watch that video. So here this header file is included because I am using the built-in function printf. So this code, this function declaration has to be replaced here. That is what the preprocessor is going to do with. The preprocessor is going to replace the declaration of the function. Talking about the function, we have three things. We have three parts of the function. We have the declaration, we have the call, and finally we have the definition. So here what happens, this is a function actually, but it's a built-in function. A built-in function will have its, not only built-in function, even user-defined functions will have its function declaration, function call, and function definition. What the preprocessor will do, the preprocessor will replace the code of the header file. So we have included this header file for this inbuilt function printf. So I need to declare this function. So the code of stdio.h will be replaced there. Then I'll get all the macro definition filled. So macro values will be filled. Then I will have the main function and all the other code remains the same. But the macro max value will be replaced there. So we have given 10. So the macro value will be replaced. So these three tasks will be done by the preprocessor because compiler cannot make out these preprocessors directives. Only the preprocessor can include the header file, can identify the macro, and it will do all these tasks. And then this output, that what we have got the code of the header file, that is the built-in function. Then we have the complete main program and the macro values filled. So this code is given to compiler. So this code is given to compiler, and what the compiler will do. So this is what the outcome of preprocessor. So we have the code of stdio, we have the main, and we have the macro value replaced. So now this code, we call it as expanded code. It is expanded code, or we can also call it as intermediate code, because we have got the code of all the header files here, because the built-in functions that what we have used in the program, those built-in function definitions we need to get. So we need to have the declarations of those header files. So that code we have got, so it has been expanded. We have the macro definitions here, and that is being expanded. So we call this complete code as expanded code, or we call it as intermediate code. So this intermediate code is given to compiler. It is given to compiler. So what the compiler will do, it is going to translate the program and actually saying we get the outcome in the object code. The compiler will do the translation, error checking, everything. Once the program becomes free from errors, then we get the complete program in machine code. But there is one more phase which comes into picture, and that phase, the outcome of the compiler will be in assembly code. So what is this assembly code? It will be in mnemonics. So we will have the mnemonics. So we have the source code in English-like statements. Of course, it may be in an expanded code. We have the English-like statements, and when we give this to compiler, and compiler will convert this into assembly code into mnemonics, means we will have something like add or move like this. But again, this mnemonic code is not interpreted by machine. The machine can understand only the binary language, zeros and ones. So we give this assembly code, that is the mnemonics, to assembler. And assembler is going to translate your code, assembly code. See, the outcome of compiler is assembly code. And this assembly code is still in mnemonics where machine cannot understand. So we have to make the machine to understand. So we give this mnemonic codes to assembler, the translator, which gives you the output in binary codes, zeros and ones, something like this. So my output of this assembly code will be something like this, not exactly, something like this in the sequence of binary codes. So here we have the binary codes. So the expanded code, intermediate code given to compiler, and compiler will come out with assembly code, and assembly code is given to assembler, and assembler translates that to the binary codes, and the outcome of this is called as object code. So we have the source code to intermediate code given to compiler, and finally this is the interface, that what we have not seen. So that interface is here. Assembler translates to binary codes and we get the object code. Well, we will have many objects code like this, because when I say a program will have many modules, and each and every module will come out with different object codes. And finally, I have to link all these object code. This is one thing. And when I group all these object code of different modules I need to link, then I use many inbuilt functions. So I need to get the definitions of all those inbuilt functions. Say I have used printf, I may use clear screen function. So all the built-in functions, so if I have used some mathematical functions, square root, power, all these inbuilt functions definitions I need to link. So the inbuilt functions definitions has to be linked. So once I get this object code, different object code has to be linked, and the definitions of the inbuilt functions, call is done. Printf is a call. Inside the main function we make a call. When the call is done, it is going to check whether it is declared. So the preprocessor has done that. The declaration is replaced. And now it's time to get into the definition part, where I need to get into the code of all these inbuilt functions, and that task is going to be processed by one more, which is linker. So that is what we say, translation is one stage. So compilation model works in 3 stages: translation, linking and loading. So now we are in this linking stage. So we are going to link all these object code and the definitions of all the inbuilt functions with the help of linker. So compiler is done. It is going to create the assembly code, and assembler is going to convert to object code. Source code to intermediate code to, we have got this object code. Now this object code has to be linked with all these things with the help of linker. So once the linker links all the object code and the definitions of all the built-in functions, it is going to create one single file, and that single file, that is an executable code, it is going to create, which is demo.exe. So the file is ready for execution now. So I need to execute my program. So here loader comes into picture. So loader is going to load your exe file, which is ready for execution, to the main memory, that is RAM. So it is sent to the processor, and processor is going to process your program, and then if there are any errors here, that is runtime errors, we are going to get those errors. But if there is no errors, if it is free from errors, then finally we are going to get the output of the program. So this is what the complete process of the compilation and execution. So the source code, say demo.c, given to the preprocessor first, the in-between phase. It converts the source code to the expanded code. We also call it as intermediate code. Then finally it is given to compiler, and the compiler will convert that expanded code to assembly code. And again assembly code I need to convert. So I'll give this assembly code to assembler, and assembler is going to convert this assembly code to object code. So from .c I got .obj. So my object file is ready. So I have to link many object files, the definitions of built-in functions, all those things, and I need to create one single file. Then I'll be getting an executable file, that is demo.exe. .c to .obj, obj to exe. That is source code, object code, and executable code. So my executable code is ready. I have to load that to memory, and once I load the program, the executable program, to the memory, the processor will take care of it, and it is going to execute my program. If there are no errors, if it is free from errors, then I'll get the output. So this is what the complete compilation and execution process. So that's all for today's video. So let's see in the next video. Till then, take care. Bye-bye.